Advanced Resilient Technology Limited, also known as ART, introduces the world's most important change in engine technology since the invention of the internal combustion engine. Until now, advances in the internal combustion engine have been only mechanical. The ART Zajac engine offers the first advance that is based in chemistry, allowing our engines to be a true game changer. Today, using plasma technology along with space-age materials and simplified mechanical components, the ART Zajac engine is the first and only internal combustion engine that runs at a constant temperature, delivers constant torque, and maintains constant compression pressure. These changes allow the ART Zajac engine to burn fuel completely, therefore providing a much more efficient and virtually non-polluting solution for power generation and transportation. The engine can be used in many markets to generate ultra-low or zero emissions energy. Syngas, made by ART's biochar production, together with the ART Zajac engine, produces clean electricity and completes the triple bottom line of transforming waste into value. Other markets that could benefit from the clean-running ART Zajac engine are the container ship market, where one container ship generates emissions equal to the exhaust of 50 million cars. It can be used anywhere gas is being flared by using the flared gas to produce clean electricity. Presently, 5.3 trillion cubic feet of natural gas is flared unproductively annually, producing 400 million tons of CO2, an amount equal to half the emission reduction required by the Kyoto Accords. The ART Zajac engine supports current fuel and manufacturing infrastructures. It is biofuel ready and can run on any liquid or gaseous hydrocarbon fuel, even unrefined crude oil, on the fly with no change in performance or cleanliness. In addition, the ART Zajac engine is designed to be built onto existing engine blocks and fit in with current manufacturing production. Standard gasoline and diesel engines run inefficiently, burning only a portion of the fuel they consume. What isn't burned in the combustion stroke is eliminated into the atmosphere as polluting emissions. The reason for this inefficiency is that the cylinder walls have to be cooled to prevent damage from excessive heat. The cooling quenches the combustion flame and prevents a complete burn, thus limiting efficiency. With our breakthrough technology, the ART Zajac engine eliminates cold cylinder walls and instead uses a unique hot wall reactor in which fuel burns at a constant temperature of 1425 degrees Celsius. Constant pressure in the combustion chamber eliminates the power delay caused by the valve's opening, thereby improving efficiency and eliminating the need for a muffler to dampen exhaust noise. Idling at a low 70 RPM, the engine produces exhaust clean enough to breathe, with nitrous oxide less than 18 parts per million. The ART Zajac engine burns so clean that valves and pistons don't get dirty, which saves on maintenance costs. Instead of every 5,000 miles, oil changes are now 50,000 miles apart. Let's take a closer look at how the design of the ART Zajac engine increases efficiency and cleanliness.
Welcome to the Zajac Motors Demonstration Lab. In this lab we have equipment which demonstrates how cleanly we can burn any fuel. Today we will be burning number 2 diesel fuel.
The ART Zajac engine uses common parts in an improved way.
Because our system is not fully integrated, awaiting the valves to control the engine, we have set up on the dyno a high-pressure compressor which will pump air into the combustion chamber. This high-pressure pump is rather noisy, so we have mounted a muffler to the air intake to help reduce the noise. The compressor is controlled by an electric motor which we control the speed of very accurately, so we know the amount of air intake.
Following the airflow, you can see that inefficient throttling is not used. Instead, variable valves are used to control airflow. Another efficiency feature is that the compressor always compresses the air to the same high pressure, whether at idle or full load.
The compressed air then travels from the high-pressure compressor to the combustion chamber. Our R&D combustion chamber is oversized because it's for R&D use. Each engine has just one combustion chamber. Each combustion chamber has only one fuel injector and one glow or spark plug.
Injected fuel resides in the hot wall combustion chamber longer than in other engines, so that time and temperature can provide complete and totally clean combustion. This gas then goes to the expander. Unlike other engines, the pressurized gas is fully expanded to provide maximum efficiency.
Meaning that the exhaust is virtually only carbon dioxide and water vapor. The gases come out the bottom of the combustion chamber and go into the engine block to push the pistons and do work.
When the gas is exhausted, it is so clean and quiet that catalytic converters and mufflers are not needed.
We will now start the electric motor to run the compressor. This is fairly noisy and noisier than a normal engine would be. In a normal engine, the sound would be only that of the first couple of cylinders in the engine block. The noises that you hear are not normal to the concept of this design. Here we are in the lab with the compressor running so you can hear it running. That is all the noise in the background. You'll notice no increase in sound when the engine starts. Here you can see the pressure of only 4.5 to 1 compression ratio to start, with much easier than other engines. You can also see the temperature here and here for what's taking place inside the engine. This will be a cold start. I will ask for fuel by clicking this button, and there'll be about a 3-second delay for the computer to process and then display temperature. But watch the temperature rise as we start, and notice no increase in sound. We now have ignition because it actually gets quieter. And these boxes are 2 seconds per box, and you can see in the space of 2 seconds we are over 1,000 degrees, climbing to 1,200 degrees in the combustion chamber. Looking at the exhaust of this cold start with the bright light showing, you can see that there is literally no smoke, no particulate. There is absolutely nothing coming out of this engine to be filtered or cleansed. Here you can see we're at 1425 degrees C, which is our main range of operating. The temperature is constant. If we zoom over to the combustion chamber here, you can see that it is cold to the touch. Internal and external insulation prevents this from ever getting warm. Meanwhile, listen also to the sound. The sound is only of the fuel injector and the compressor. There is no sound emanating from the combustion chamber itself. And if we look at the pollution levels, you will see that the CO is 0, the NO2 is 0, and the NO is 16 parts per million. This is a clean running engine on number 2 diesel. This is what the world needs.
The ART Zajac engine is truly a game changer. For more information about Advanced Resilient Technology Limited or the ART Zajac engine, go to our website, art.co.im.